Good day. It is indeed a pleasure to present improving health and safety on South African construction projects with Industry 4.0. I am Professor John Smallwood and I represent Nelson Mandela University based in Port Elizabeth, South Africa, as the principal co-author Nobukhosi Mazibuko. Despite HNS legislation and regulations having been evolved and implemented, there's been a limited reduction in accidents. HNS related challenges have persisted despite a range of HNS related developments and interventions. Research findings in turn indicate that the advent of Industry 4.0 and a range of related technologies, if adopted, have the potential to provide a long-lasting solution to construction HNS related issues. Given the continuing poor HNS performance recorded in the South African construction industry, a study was conducted to evolve a framework of interventions to improve HNS using Industry 4.0 technologies. The objectives of the study being to determine the occurrence of HNS phenomena on construction projects, the extent to which HNS related processes need improvement in construction, potential of Industry 4.0 technologies to improve the HNS related processes in construction, level of awareness or knowledge of Industry 4.0 technologies, potential drones to improve HNS related processes, the potential BIM to improve HNS aspects of HNS, and potential wearables and sensors to mitigate fatalities, injuries, and illness. Research method and sample stratum. The quantitative research methodology was adopted for the study. The sample included 70 potential respondents in the form of general contractor members of the East Cape Master Builders Association and HNS practitioners, construction managers and construction project managers in the Eastern Cape registered as candidate and professionals with the SACP-CMP, the statutory council. The questionnaire consisted of 18 questions, 17 closed-ended and 1 open-ended. 10 of the closed-ended questions were Likert scale type questions and 7 were demographic related. 31 responses were included in the analysis of the data, which equates to a response rate of 44.3%. Descriptive statistics included frequencies and a measure of central tendency in the form of a mean score. Table 1 presents the frequency at which HNS phenomena occurred on the respondents' construction projects. There are 8 phenomena, and the second column from the right-hand side presents the mean score, which is between 1 and 5, the midpoint being 3. It is notable that only 2 mean scores are higher than 3, which means that these phenomena are experienced frequently as opposed to infrequently, namely workers experience fatigue and on-site hazards. Third-ranked injuries and fourth-ranked design-originated hazards are encountered on-site, follow shortly thereafter with mean scores of 2.97. Thereafter, illnesses follow, ineffective HNS training, difficulty in monitoring HNS on-site, and lastly, fatalities with a mean score of 1.57. Table 2 presents the extent to which HNS related processes need improvement in construction. This is on a scale of minor to major, the mean scores being between 1 and 5. It is notable that all the mean scores are above the midpoint of 3, which means that there's a major as opposed to a minor need for improvement in HNS related processes. First rank mitigation of injuries is followed by reduction of design originated hazards and thereafter by mitigation of fatalities, automation of on-site activities, monitoring HNS hazards on site, mitigation of illnesses, reduction of workers' fatigue, reduction of construction-originated hazards, and lastly, HNS training. Table 3 presents the potential of Industry 4.0 technologies to improve the HNS related processes in construction on a scale of minor to major. It is notable that 8 of the 9 processes' mean scores are greater than 3, which means there is more major potential than minor potential in the case of those 8 to improve the H&S related processes. First ranked automation of on-site activities is followed by H&S training, then reduction of design-originated hazards, monitoring H&S hazards on site, fatigue experienced by workers, reduction of construction-originated hazards, and then mitigation of fatalities, mitigation of injuries, and mitigation of illnesses. The mean score thereof being on the midpoint, namely. Table 4 presents the respondents' level of awareness and knowledge of Industry 4.0 technologies on a scale of limited to extensive. There are 6 technologies presented. 3 of the 6, that is 50% of the technologies' mean scores, are above the midpoint of 3, which means the respondents' level of awareness or knowledge related thereto is above average as opposed to below average. BIM is ranked first, followed by automation, followed by drones. Virtual reality is ranked fourth with a mean score of 2.97, just below the midpoint of 3. That is followed by wearable technology / sensors, and lastly by robotics. Table 5 presents the potential of drones to improve H&S related processes on a scale of minor to major. There are 3 processes. 2 of the 3 processes' mean scores are above the midpoint of 3, which means there's major potential as opposed to minor potential to improve those H&S related processes using drones, identifying H&S hazards, and monitoring H&S hazards in construction. The third ranked process, reducing H&S design originated hazards, has a mean score of 2.7. It could be argued, or it can be argued, that 2.70 is not that far below the midpoint of 3. Table 6 presents the potential of BRIM to improve aspects of H&S. There are 3 such aspects. Once again, a scale of minor to major. All 3 mean scores are above the midpoint of 3, which means there's more major than minor potential to improve these aspects. And firstly, reducing H&S design originated hazards is ranked first, and that is followed by identifying H&S hazards, and lastly, reduction of construction originated hazards. The linkage between BIM and design originated hazards should be noted. Table 7 presents the potential of wearables and sensors to mitigate fatalities, injuries, and illnesses. On a scale of minor to major, there are 3 impacts as such, and 2 of the 3 impacts, namely mitigate fatalities and mitigate injuries, have mean scores greater than 3, which means the potential is more major than minor. Mitigate illnesses is ranked third with a mean score of 2.93, just below the midpoint of 3. Conclusions: given the frequency at which H&S phenomena occurred on respondents' construction projects, it can be concluded that respondents experience the majority of these phenomena on their construction projects. Given the extent of the need for improvement of H&S processes in construction, it can be concluded that the perceptions of the respondents reflect the general experience in construction in South Africa, which amplifies the need to implement Industry 4.0 technologies. Given the respondents' level of awareness and knowledge of Industry 4.0 technologies, it can be concluded that there is a need for an increase in the level of awareness through education by tertiary education programs and to integrate these technologies into construction training. Given the potential of Industry 4.0 technologies to improve H&S processes in construction, it can be concluded there is a need for the implementation of Industry 4.0. Given the potential of drones to improve H&S processes, BIM to improve aspects of H&S, and wearable sensors to improve H&S related processes, it can be concluded that there is the need for the implementation of these Industry 4.0 technologies in construction. Given the size of the sample and the geographical location of the study, the findings cannot be deemed to be representative but indicative. Furthermore, the findings are perception-based, not confirmed by research. Terms and recommendations, the CIDB should compile Industry 4.0 and construction guidelines. Construction H&S related training and tertiary education should address Industry 4.0 technologies. A range of industry stakeholders should promote and preferably deliver Industry 4.0 related construction H&S CPD. Contractors should implement the relevant Industry 4.0 technologies. Contractors and researchers should conduct experimental research to confirm the perceived potential of Industry 4.0 technologies to contribute to improving H&S performance.